Good morning.
Good morning, Deb.
Good morning.
Morning, Deb.
Good morning.
Good morning, Ted. Let's see.
Good morning.
Good morning, Shaq. Good morning, Anna. AK. Okay, girls. Did you guys try to do the question and exam review? Okay. Any issues? Okay. A lot of issues? Okay. Okay, girls, let's just, now some of them are going to be, you can say it's okay. Somehow. Straightforward, some of them maybe it's okay. Need, you can say it's okay. A little bit more of okay as discussion or whatever you want to call it. Okay. So let's just okay, yes. Try to go over them. Yes. Let's see. But there's something that you still don't understand. As we go through the questions, please ask us. Now is the time, okay? So we are question number 50 on page 432. Now, what is the range of period formed as okay, commonly found in waves you produced by ultrasound? Yeah, so the main is okay, just asking us about is okay, the normal range. Which was this? Clear? Now, ladies, there's 0.06 microseconds here can also be written as 0.06, and the micro can be written as 10 raised to the power -6, and then it's going to be as okay, simply as okay, just a second. So when you look at 0.06, this number here itself is okay as a fraction of a microsecond. actually is okay 100th of a microsecond. Clear? Okay. So if you want, yes, okay, write this 6 here as a whole number. Then we can mean it's okay, 6 becomes 6. I mean it's okay because it's always a decimal, it's a 2 decimal number. That's why it's okay, it becomes -2 plus -6, which becomes a total of -8. And your unit is still second. Right, okay. Whereas over here, this fellow here, 0.5 mainly as okay is the same as say it's okay a half. Clear? Okay. But we can say it's okay. The same applies that okay as 0.5 is 0.5. That micro actually is okay will become, you can say it's okay, 10 raised to the power -6. And don't write microsecond because it's okay, this here is the micro, so it's okay, second becomes second. Clear? But if you want, yes, okay, write this here as a whole number. And say, I don't want decimals or anything, yes, okay, that's when you mean, yes, okay, just go 5. Now it's 1 decimal number, so it becomes, yes, okay, -1 plus, we can say it's okay, -6, which becomes just okay, we can say it's okay, a total of -7. So it can also be written as 5 multiplied by 10 raised to the power -7, and okay, yes, the unit is still second. Clear? But that was okay as the typical range of the period of a ultrasound cycle. So what was that? The time that it takes from here to here. Okay. Please keep in mind, girls, that's okay when we say period and period only. That is going to be as okay the time for one cycle to complete. One cycle, like we can also say that's going to just okay be 1 week. And this here is okay, that is 1 week. Okay, where it goes up and when it goes down. This is 1 week. Did you ladies get that? Okay, so here maybe yes, okay, just asking into yes, okay, what is the normal range of what you can call it, the period. Okay. Okay, now what happens to an ultrasonic? Okay, now okay, let's see. With standard ultrasonic imaging, what happens to the period of the wave as it propagates? Now, what does that mean? That means it says, okay, we have a transducer. This transducer is okay, produces a sound wave, which has okay, yes, a period. Okay, it mainly is okay, just ask, okay, yes, what is going to happen to this period here as the sound wave travels through the body? Okay, so is it going to increase? What that will mean is that sound wave is okay, going to increase in period? Is it going to decrease? Or is it going to remain the same? Now we said, if you look into it, okay, when it says, okay, sound wave determined by, that was the source. Clear? And it doesn't really say anything about, yes, okay, the period increasing or the period decreasing as the sound travels through the medium. Clear? So that's okay. The period of the sound wave is going to remain unchanged. Clear? If we say amplitude, if we said something like intensity and power, so on, so then we know for sure that, okay, yes, had it been the same question what they had asked, what happens to the power, then that would have decreased as it traveled through the body. Is that clear? Did you ladies get that?
Yeah.
Good. Now, next question. What determines the period of an ultrasound wave? I already said that. That was determined by the source. And in this case, yes, okay, what do you mean by the source? When we talk period, when we talk frequency, the source is going to be, yes, okay, the transducer. Okay. Question number 53. Now, which of the following units are appropriate to describe period of an acoustic sound wave? More than one may be, more than one answer may be correct. Yeah. Now, girls, the main thing that you need to know is, okay, what was the type of unit in which period was expressed? Time, because it counts for the time that it takes for one cycle to complete. So that's okay. In the units that we are given below, any unit that is going to be as okay, a unit of time is going to be as okay, the unit for a period. A minute, that's a unit of time, that's going to be as okay. That could be the unit of the period. Clear? Microseconds. Now, whether you write it like this, whether you write it like this, or whether you write it like this, it's the same. Clear? Or whether you write it like, okay, yes, this. Or this. That's all, yes, okay, different ways of, okay, yes, writing microsecond. But you can say, it's okay, basically, it's okay. Second was a time, or was a unit of time. So it's okay, a millionth of a second is also going to be, it's okay, time, just pretty short. Clear? Meters. Now, meters goes, that's going to be, it's okay, a unit of distance or length. So I had your question here asked, which of the following units may represent, or maybe it's okay, would be appropriate to describe wavelength? Then meter could have been an answer. Okay. Probably not an ultrasound wavelength, but that's not what they're asking here. They just say, okay, wavelength. But okay. Millimeters per microsecond. That is the unit of speed. Okay, so don't fall for that, okay, that it has, okay, as the unit of time in it. Because, okay, the unit of time is okay, here is okay, coming together with, okay, as distance makes it, okay, as a whole different unit. Clear? Okay, which in this case here is going to be speed. Cubic millimeters, or cubic centimeters, sorry. Okay, that was going to be as, okay, the unit of area, volume, sorry. Okay, so that's okay, whether it was a minute, whether it was a microsecond, millisecond, macrosecond, nanosecond, whatever, are okay, appropriate units of time, and hence being as okay appropriate units for a period of the sound wave. Any questions so far, girls? True or false? Now, so an sonographer has the ability to alter the period of an ultrasound wave that is produced by a basic transducer. Now, I'm saying this is okay. Basic transducer. We are not able to, yes, okay, alter the period. So that statement here is false. Clear? Okay. Now just be watchful, girls, because I had the same statement as okay being as okay. Not the same, but as okay, if they put the word not, then it becomes true. Okay, so we do not have the ability to, yes, okay, alter the period or adjust the period using a basic ultrasound transducer. Yeah, but here it's okay. They're asking, do you have the ability? No. Clear? So that becomes false. What term describes now? Okay, listen. Question 53, 55. Now, what term describes the number of cycles that an acoustic variable completes in a second? Clear? Okay. So we can make it okay, just say it's okay, number of cycles in a second. That is going to be a okay, a frequency. Clear? And it just said time for a cycle to complete. And that would have been period. Okay, now what a pulse repetition period is going to be. That's something that we will talk about is okay in the next chapter. Okay, so yes, okay, they may yes, okay, put this option here as okay, thinking that you have finished the whole book. Okay. And okay, as a variable rate, that's really nothing. That means it means okay, a rate that is able to change. Clear? Any questions? So girls, any frequency was mean that's okay, there's going to be how many cycles? Did we first yes, okay, have in? Let's say 1 second. Or this could have been yes, okay, a microsecond. Then the frequency will just become greater. Yeah, okay. If we say second, yes, okay, 1, 2, 3, 4, 5, 6. So here we had 6 cycles per second, which means that 6 is 6. And okay, as this cycles per second here is okay, becomes hertz. And we said that this period here is okay, it was let's okay, 1 microsecond. We still had 6 cycles in 1 microsecond, then it's going to be okay, 6. But because it's microhertz, then the frequency will become megahertz. Because it says, okay, 6 cycles per microsecond. Okay, in this instance here, it's okay, your period will have been 1/6 of a microsecond. Because this was 1 second, so yes, okay. It took each cycle 1/6 of a microsecond to complete. So when you add up these 1/6 of a microsecond, you got 1 microsecond. Oh yes, okay, even in this other case, if you said, okay, that was just, okay, 6 cycles per second. Then, okay, yes, the period of each cycle was going to be, yes, okay, 1/6 of a second. Because 6 cycles were completed in 1 second. So when you add up 1/6 of a second, 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 6 times you have, okay, as a total period of 6 seconds. But each 1/6 of those seconds or 1/6 of that second, 1 cycle will be completed. So that's going to be, it's okay, the time that it took for 1 cycle to complete. And when you see here, it's okay, you multiply 1 by 6 by 6. What you get? 1. The same here, 1/6 by 6. You still get 1. But then you just have to keep in mind that, okay, as when you say microseconds, it's going to be, it's okay, frequency in megahertz. If you say milliseconds, then it's going to be, it's okay, a frequency in kilohertz. If you had said, yes, okay, nanoseconds, then your frequency is going to be, it's okay, in gigahertz. Any question, ladies? Now, which of the following cannot be considered as a unit of frequency? Then you can say, it's okay, per day. You may say, it's okay, naps per day. Or anything is okay per a unit of time is going to, yes, okay, is a frequency. If you say, it's okay, I take 10 naps a day, then your frequency is going to be, it's okay, 10 naps per 24 hours or 10 naps per day. But that means it's okay, that tells you, it's okay, how frequently do you take a nap? Clear? Cycles per second. We just said that. I mean, it's okay, where V is okay, in ultrasound, it's okay, call, it's okay. Or especially, it's okay for waves. We'll use cycles per or waves per second as a unit. This could also, as okay, be as okay, abbreviated as hertz. HZ is mainly as okay, just the abbreviation for what we call hertz, which happens to be as okay, the unit of frequency. Okay. Cycles is not a unit of frequency. Cycle just say, well, okay, that's a cycle. You may say it's okay, 2 cycles or 3 cycles. That's just going to, you can say it's okay, give you a count of cycles. But since it does not specify the time that it takes this number of half cycles to complete, yes, okay, that does not make it, that causes it not to be considered as a frequency. Did you girls get that? Any questions so far? Good. My responsibility is to ask, and your responsibility is to say, yes, we have a question, and then ask it. Question 57. Now the mean is okay, just okay, what was the normal range of frequency? Or transducer used in ultrasonic imaging. So we can say, okay, for ultrasound. And we said, okay, yes, we said that I was 215 megahertz. Now here it's okay, they mainly it's okay, just wrote the megas. But okay, as a series of six zeros. Clear? Okay. Now just remember, guys, this could also be written as, sorry. Yeah, where we can mainly says, okay, this here and this here is okay, does become your mega. 2 is 2, 15 is 15. And okay, then you just have your hertz. Did that make sense? Now I may ask a dumb question. What's going to be the wavelength for this fellow here? Anybody?
Would it be 2/1 million? 2/1 million? No, okay.
No, why would it be that? I'm not asking of your period, my dear. I'm asking for the wavelength.
Oh, I have a question now.
Which is,
Is it always gonna be the 1.504, even if the numbers are different, like the hertz number?
yes,
Oh,
for soft tissue. For
okay.
soft tissue, this number here is going to be standard.
Oh, that's where I'm confused. Okay.
Where did that come from? The speed of sound in soft tissue. Okay.
Yeah.
So it's now 1 to 3 megahertz. It's not 1 to 1,000 kilohertz. Let me just ask another question then. What would be another way of saying it's okay, 1,000 kilohertz? What is that going to be equal to?
Is it 1,000 millimeters? No? Okay.
Dr. King, what is going on with you here?
Life is happening.
Can it be 1 times 10 to the power of 3?
Okay. 1 times 10 raised to the power 3. Horses, donkeys, donuts, cups of coffee.
Hertz. Sorry, I'm sorry, I didn't put the hertz. Yeah.
Hertz. Okay. My dear, I don't know which thousand you ate. Either you omitted out this 1,000 here or you omitted out this 1,000 here. It can be as okay 1,000 kilohertz. That's how you can write this. Could be as okay how you write 1,000. You still have to as okay go for your kilohertz. So 1,000 kilohertz, girls, is we can say it's okay either because this here becomes 10 raised to the power 3. This is another 10 raised to the power 3. So that becomes just okay.
Yeah,
And then you
I
go
get it
up.
now. I get what I got
So
wrong.
it actually becomes 1 megahertz. Okay. So saying that, okay, as $1,000 bills is equal to 1,000. Okay, yes. A 100, no, it's okay. It's okay. 1,000,000 and 1,000 can't be equal. So it's okay. That 1,000 kilohertz actually is going to, it's okay, be 1 megahertz. Or we can say it's okay. On the other hand, you can also say it's okay, 1,000 megahertz. Now, what is that going to be? If you say it's okay, it's going to, it's okay, be 1,000 hertz. What the hell happened to this one here? This still means that's okay, 1,000. Oh, sorry, 1,000,000, right? Okay. Okay. So you can say, okay, 1,000 megahertz is going to be as okay, 1 giga. Because okay, here this 1,000 is a 10 raised to the power 3. This mega here is okay, yes, 10 raised to the power 6. Now you add these two, that makes it then 1 gigahertz. So in option C, well, okay, let's not go to the minus, but we can say it's okay because that's unlikely to happen. But if we just say it's okay, if you write something like this, 10,000 hearts, what would that be? You can say it's okay. You can do it this way. You can say it's okay, 10 is 10. The 1,000 here can either be expressed like this, or you can write it as, okay, as a key. And then hearts just become hearts. So 10,000 hearts is going to be as, okay, 10 raised to the power, 10 multiplied by 10 raised to the power 3 hearts. Or you can say as, okay, 10 kilohertz. Clear. You can further, yes, okay, simplify this one here and make it, yes, okay, 1. Now you can say, okay, multiply by 1 raised to the power 1 plus the 3, and then hearts. So this says, okay, actually becomes 10 raised to the power 4. That this 10 raised to the power 4, actually, what does that mean? That means 10 multiplied by 10 multiplied by 10 multiplied by 10. When you do that math, it becomes 10 times 10 is 100 times 10 is 1,000 times 10 is 10,000 hearts. Did you girls get that? Don't just nod if you didn't get it. Okay, so the unit, okay, the donor frequency was, okay, as 2 megahertz to 15 megahertz. Okay. But can you write 15 megahertz in different ways? Yes, you can. Okay, you can say it's okay, 15 megahertz or 2 megahertz, for instance. That can be 2,000 kilohertz. That is still the same as 2 megahertz. Because, okay, here, one of the 1,000 is here, the other 1,000 is here. So kilohertz mainly means 1,000 hertz. So 1,000 here and 1,000 here. Which means 1,000 times 1,000, which becomes a million. Okay, question 58. What establishes the frequency of an ultrasound wave? Okay, it may, yes, okay, just asking, yes, okay, what determines the frequency? Here, is that going to be the medium? Is that going to be the transducer? Is that going to be, yes, okay, both? Or is it neither? So yes, okay, if you have read your text and paid a little bit of attention, you would know that, okay, yes, what determines the frequency is going to be, yes, okay, the transducer. Which is source. Now you may get the same question where it says, okay, source. and says, okay, in one instance, okay, option for source as okay is the transducer. Another source, another part of the source is system. Clear? It is still going to be the transducer. In that case, okay, all that's okay. System is okay as a part of source, but that's not going to be as okay. What will determine the frequency? It is the transducer of your imaging transducers that will determine the frequency of the sound wave. Did that make sense? Did that make sense?
Yes.
Good. Question 30, okay, let's see, 59. With standard ultrasound pulses, the frequency of an ultrasound changes significantly as the wave propagates through the body. So the main is okay asking is this, sorry, is the frequency changing as the sound wave travels through the body? And the question here is no. So that means okay, makes the statement false. The ultrasound frequency does not change. Ever had been a different case had it said hour, had it said intensity, or had it said, for instance, okay, amplitude, then your answer would have been yes. I just says, okay, that, okay, as the power changes, the power amplitude changes, intensity changes as the sound wave travels through the body, then yes. To be more specifically, that's okay, that change would actually, that's okay, because there's okay, be a decrease in the power. There will be a decrease in the amplitude and intensity. Okay, but for frequency, if the sound wave had a frequency as okay here of, let's say, it's okay, 2 megahertz, it's going to remain 2 megahertz at a depth of, let's say, 2 centimeters. Here is okay, when you go to a depth of, let's say, it's okay, 3 centimeters, the frequency of the sound wave here is still going to be 2 megahertz. So it does not change. Did you girls get that?
Yes.
Good. Question number 60. When a sonographer, let's see, it's okay. When a sonographer increases the maximum imaging depth during an exam, what happens to the frequency? Nothing. You can say it's okay, your depth of image here is okay, maybe it's okay, because it's okay, 3 centimeters. You can say it's okay, you increase it to, let's say it's okay, a depth, your image to it's okay to a depth of 5 centimeters. Nothing happens to your frequency. First of all, it's okay because it was determined by the transducer. Because it's okay, 3 megahertz, and okay, it's same transducer, but 3 megahertz. The frequency is going to be 3 megahertz at this depth, and even at this depth. Like I said, this will be 1 centimeter, 2 centimeters, 3 centimeters. The frequency is going to be the same at all depths. Okay, girls? Likewise, you can say it's okay. The same will apply here, whether it's okay, it was 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, and 5 centimeter. At all these depths, you're going to have is okay the same frequency because it does not change. The frequency does not change. If it was 3 megahertz, it's going to remain 3 megahertz. If it was 7 megahertz, it's going to be remaining 7 megahertz. Did you ladies get that?
Yes.
So the frequency remains unchanged. So does the period. Question 61. Now, ultrasound is defined as a sound wave with a frequency of. Now, what did we say that, okay, as, oops, sorry. An ultrasound wave was. Okay, it was made as, okay, going to, yes, okay, have a frequency that was greater than, sorry,
Okay.
20,000 hertz. Or we can say it's okay, 20. Now I come back to the same. This is just going to be kilo, and then you go with your hertz. Clear? So any frequency or any sound wave with a frequency greater than 20,000 hertz was going to be considered an ultrasound. Now, when we go very, very, yes, okay, high up on that scale, yes, okay, 2 megahertz, that's where it's okay, because that's okay, our imaging ultrasound wave starts. Because that was okay as the minimum range of, let's say, it's okay, our ultrasound, imaging ultrasound sound waves that we use for ultrasound imaging. Clear? Okay. But any sound wave greater than 20,000 hertz, because, okay, anything that produces a sound greater than 20,000 hertz, well, it is still a sound, but you will not be able to hear it because it's beyond the, what you can call as, okay, ability of the human ear to detect. Did you ladies get that?
Yes. So it could have been A or D.
No,
Why not A?
because A is 20,000 kilo, or yes, okay, 20,000 kilohertz.
Yes, I got it now. Thank you.
Ladies,
I keep
you have to
forgetting
look at the number, you have to look at the units. And it just said 20,000 hertz. Then it would have been 20,000 hertz. When you put a kilo in front of the hertz, it becomes just okay 1,000 hertz. So 20,000 hertz and 20,000 kilohertz can't be the same. It's not saying it's okay, a stack of $1,000 bills is equal to it's okay, a stack of $100 bills. Where you have okay, 1,000 bills in most stacks. If that's the case, I got a lot of $100 bills that I want you guys to just okay, exchange with me then. So when you say kilohertz means that's okay, 1,000 hertz. So it's okay, there's a small detail here. taken off, yes, okay, had there not been a K in option A, then okay, yes, that could be a correct answer. Did that make sense?
Yeah.
Okay, so watch out, not just for the number, but also yes, okay, for the units. And every part in the unit is okay, as well as okay, is important. Now, an infrasound is defined, okay, as a sound wave with a frequency. Okay, a dumb question, but maybe that's okay since they mentioned it in the book. Anything less than 20 hertz. Clear? Okay, anything less than 20 hertz. Okay, and they mean, so, okay, we're not going to waste our breath on that one. Okay. So please go, that's okay. Just remember that, okay, yes, the audible range was 20 hertz. To 20 kilohertz. No, and again, yes, okay, listen. If you don't pay attention to this, you will mainly say, yes, okay, 20 hertz and 20 kilohertz is the same. Hell no, they're not the same. Because this is just 20. This here actually is okay, well, the 20 is still 20. But then you have, yes, okay, a kilo, which actually means 1,000. Or you can say it's okay, 1,000. Clear? So it actually becomes 20,000 hertz. Or you can just say 20 kilohertz. Okay. But if you don't, just okay, take into consideration, it's okay, kilohertz as the unit, then you can say, okay, 20 hertz and 20 kilohertz will be the same. Now, this kilo actually means is okay, 1,000. Okay, so anything less than this, that is infrasonic. Anything greater than this, yes, okay, will be ultrasonic. And far, yes, okay, up on the ultrasonic scale. It's going to be, okay, we can say, okay, the minimum range of ultrasound waves that we use for diagnostic imaging. Okay. You can say it's okay, a wave with, okay, yes, a frequency of, let's say, is okay, 2 hertz, okay, 20,000 hertz or 25,000 hertz, sorry. Or you can say it's okay, 25 kilohertz. It's still, yes, okay, ultrasonic, but it's not going to, yes, okay, be used for ultrasonic imaging. US, okay, wave with, okay, it's a 1 megahertz. It is still ultrasonic, but it's okay, we cannot use it for diagnostic imaging because it doesn't fall into that range. Did you ladies get that? The next question will be 63 then. So is it true or false to say it's okay, waves in ultrasound range behave the same manner? Okay, it's okay, behave in the same general manner as sound waves that are audible. Yes. they are sound waves. So they're still going to behave as the same as a regular sound wave. Just because they have a higher frequency, or the only thing that's going to yes, okay, be here is that okay, yes, it's not audible to the human ear. But they still yes, okay, have the same characteristics, features, variables, etc., as any regular sound wave. Did that make sense? Question number 64. Now, what are the characteristics of an acoustic wave with frequency exceeding 20,000 hertz when compared to waves having frequency less than 20,000 hertz? So that says, okay, we have a wave which has a frequency greater than 20,000 hertz. And we can say, okay, a frequency less than 20,000 hertz. But we can mainly say, okay, this one here is okay. That was what we thought, okay, was in the ultrasonic range. This one here is okay, because it's okay, was because it's okay in the audible range. Because 20,000 hertz was 20,000 or 20 kilohertz. So greater than that, ultrasonic, less than that, audible. Clear? Okay. Now, they travel more effectively as okay in soft tissue? No. Both of them can travel in soft tissues. That's fine. Okay. They travel more rapidly. No. Because I was going to say, okay, that's all determined by the medium. Okay, so whether that was a high frequency wave, low frequency wave, they will travel at the same speed through the same medium. Clear? Okay, they attenuate less when traveling in soft tissue. No. Okay, now this is probably as okay an answer that you girls may not be able to answer at this moment here. But girls, attenuation, that's mainly as okay, just what is going to happen to your power, amplitude, and intensity. That's why I said, well, okay, yes, that decrease in power, amplitude, and intensity was what we call attenuation. And attenuation is not going to affect your frequency. Yep. The only thing that is going to be different between, yes, okay, this frequency here versus this frequency here is that this is ultrasonic, which means it, yes, okay, that humans can't hear it. It is still a sound, but you can't hear it with your ears because this frequency is too high for our ears to detect. Clear? The following questions is mainly as okay, just the same. But what they mean is okay, just says okay, what about is okay, a frequency of less than 20 hertz. Very mainly it says okay, this was infrasonic. Clear? So the same option, the same everything, and the answer is the same. Okay, can't be heard by human ears. Okay. So yes, okay, a lot of questions where the main, yes, okay, just ask us about, yes, okay. Did we know, yes, okay, the normal audible range of frequencies for the human ear? If you have time, then just bring some water, okay, John?
I'm gonna look at it.
Okay. Any questions, girls? Any questions? No? Who tried question number 66? Did anybody try to answer question 66? Okay, yes, well, okay. Not you. You would know it, but okay. Okay, girls, this question here is okay. You won't be able to get it because the topic here that they're asking is okay, beauty factor. And so on, so on. So that's all is okay, something that we'll come across in chapter number 4, which we haven't started yet. Okay. Okay. So yes, okay. Right now, just well, okay, yes. Avoid that one. I'll skip that one, you can see. Question 67. So 66 for a later instance. Once we're done with chapter 4, yes, okay, we can always, yes, okay, talk about that one. Okay. Okay, we can do okay. True or false, okay, the P, okay. 67 is also, yes, okay, something that will be, yes, okay, more clear, yes, okay, once we have talked chapter 4. Let's go to 68. Because I talk about pulses versus, yes, okay, continuous waves. Okay. True or false, the period of 2 waves are the same. Then the frequencies must be the same too. They may, yes, okay, are asking, yes, okay, we have 2 waves. Because it's okay, wave 1, wave 2. If we say that, okay, yes, both waves here, yes, okay, have the same period. Because that's okay. Wait for me, it's okay, 1 microsecond and 1 microsecond. They just asking, yes, okay, would they have the same P frequencies? Yes. Yeah, the frequency is also going to be as okay 1 megahertz, and it's going to be as okay 1 megahertz as well. Clear? So yes, okay, that is true to say that okay, as 2 waves with the same periods will have the same frequencies. Any questions? Now we can go on to question 69. Now compare yes, okay, 2 sound waves, and we can say, okay, they already have named them. Yes, okay, we say wave A versus wave B. Now the frequency of wave A is 1/3 of wave B. So we can mean as okay, just say as okay, frequency here is okay, it's 1/3 of B. Very convenient, is okay, that would mean it's okay, just make the frequency of B 3 times of A. Clear? Now, how does the period, how does the period of A compare to the period of B? Now it's just going to be opposite. The period of B is going to be, okay, 1/3 of A. Then we then now can say that's okay, that the period of A is going to be, okay, 3 times of B. Did you guys get that? Any questions, girls? Okay, Manny says, okay, that we could did it this way because both frequency and period is okay that we wrote here. Was comparing it to as okay period and frequency of wave B. And vice versa. What we wrote here. I may as okay comparing it to as okay the frequency and period for wave A. Was okay, these two here is okay, gotta be as okay when we multiply them, it becomes 1. These two is okay when we multiply them, it's still going to be 1. Did that make sense? So that's the kind of question that you will see a lot of. Where it's all about is okay, do you really know yes, okay, the relationships between the factors that they are asking? If you do, well, okay, yes, it will be straightforward too. It's okay, figure out the answer. Now here they just say as okay, last one. At least where it's okay, period and frequency is concerned. Dash is reciprocal to period. Clear? And what is going to be reciprocal to period is going to be frequency. What does it mean to be reciprocal? And that's okay when these two are multiplied and okay, that's the product become 1. Now you can go with the numbers and say it's okay. 1,000. The reciprocal of 1,000 is 1 over 1,000. This 1,000, yes, okay, can mean We can say it would be as okay 1,000 cycles per second. Where this would just mean is okay, the period then becomes 1,000 of a second. And we can say 1,000 of a second is the same as saying 1 millisecond. But okay, this 1,000 here can be as okay, it can also be as okay 1,000 hertz. But where we actually that okay can translate this 1,000 here into as okay kilo. So we have a frequency of 1 kilohertz if this period for each cycle is 1 millisecond. Did you girls get that? So girls, is there anybody who still has the least doubt or confusion about frequency and period? Ask now. Yes, okay, and nano doubt. Or how these two here, okay, work together, are related, whatsoever you want to put it. Okay, girls. Let's just look at, okay, as the next set of relationships or factors or parameters, which for amplitude, power, and intensity. Now that goes from question 71 on to 95. That goes from question 79 on to 95. Now, before I go into them, yes, okay, have anybody tried to answer these questions? Okay. Okay. That's disappointing. Okay. Okay. Anybody had any issues with any of these questions? Okay. So check when we come across those questions. If your issues haven't been addressed, let me know. Okay? Good. Let's see. Question 71. What determines the initial amplitude of an ultrasound wave? Now, go, the answer here is hidden in the term initial. Or that what makes us, okay, the answer or the correct answer is, okay, option E. Well, okay, transducer is probably not the correct answer, but it's okay. It's still better than, okay, as all of the others. It should actually have been, yes, okay, the system. Yeah. But we can say, okay, whether we say system or whether it's okay, we say transducer, they are both considered to be as okay, what we can call a source. So the initial power or amplitude intensity is always going to, as okay, be determined by source. Clear? Great. Had it said system, had it said transducer as an answer or as options, then system would have been the correct one. And that's because they just, okay, only say initial. Clear? Had the question asked you about the final amplitude, even yes, okay, power, even yes, okay, intensity, it doesn't really matter, because what we said was all your three or all your bigness parameters, yes, okay, suffer the same fate. Then in that case, as okay, would have been both source and medium. Then in this case, we can mean it as okay, as far as the source is concerned, as okay, that's going to, as okay, determine that's okay, the initial power, initial amplitude, or initial intensity. But that is okay, that's okay, that power, intensity, and amplitude is going to be as okay affected as the sound travels through the medium. I mean, it's okay, what do we end up with here as a final? It's all going to be as okay, determine as okay, what was our initial power, intensity, or amplitude, which is determined by the source. Okay. But it's also going to, as okay, be dependent upon is okay, what happens to it as it travels through the medium. So if it says final intensity, final power, final amplitude, is going to be both source and medium. If it just says initial, it's going to be as okay, the source only. Clear? And okay. Now here, since they haven't given us okay, your system as an option of source, okay, we can say okay, our transducer is not really correct, but okay, it's better than okay as other options. Okay. Is there anybody who is in doubt? True or false? With standard diagnostic instrument, okay, imaging instrumentation, the sonographer has the ability to vary the amplitude of the sound wave produced by the transducer. And that was true. Yeah, that was true. Because, okay, we said, okay, that it was adjustable. Clear? Okay. Not just your amplitude, but so was your power, so was the intensity. Yeah. What it means to be adjustable means, okay, means that we either can increase or decrease. And what we know is that, okay, if we increase the power, the intensity increase and the amplitude increase. And another way as well. If we decrease power, intensity will decrease and amplitude will decrease. But it's okay, that was adjustable. Okay, so that actually that's okay. Is going to be as okay a knob on your system by which you can increase or decrease the power. By doing so, increasing the intensity of the sound wave, which is going to okay increase or decrease the amplitude of the sound wave. Did you ladies get that? So that's okay. It is true to say that yes, okay, not just amplitude, but all yes, okay, of your three yes, okay, bigness parameters were adjustable. Is that clear, girls? Question 73. Now, as an ultrasound travels through the body, its amplitude usually. Now, not just for amplitude, but for all of your three bigness parameters. Okay. That second paragraph in determined by. Now, what did it say? As sound wave, that's okay, propagates through the body. The amplitude will decrease, the power will decrease, the intensity will decrease. So yes, okay, they usually decreases. And that decrease, that is mean, yes, okay, what we will call that's okay, attenuation. Okay. So it's only going to be as okay, these three factor parameters here is okay, which will decrease as sound travel through the body. Your frequency remains the same, the period remains the same, speed is going to change. We can't say it's okay, only decrease, because that's all going to be dependent upon it's okay, what tissue it comes through. Clear? So I may go from fast to very slow, then okay, an intermediate speed, then super fast, so on, so. So yes, okay, that's going to yes, okay, vary, all dependent upon the medium. Okay. So that's okay. As these, as okay, as sound travels through the body, not just the amplitude. The same question can be asked about power, it will decrease. The same question could be asked about the intensity, as okay, it will decrease. Did you ladies get that? Question 74. Det har det då det sa Siena. Okay, which of the following are acceptable unit for the amplitude of an acoustic wave? More than one may, yes, okay, apply. Clear? Now, girls, please keep in mind, yes, okay, then we say, yes, okay, amplitude. The first thing that I said was, okay, as any of your three acoustic variables could apply to, yes, okay, your amplitude. Where for one says, okay, one was pressure, the unit of which was Pascal. One was density, where the unit was, we can say, okay, kilograms per centimeter cube or something like that, or meter cube, but it doesn't matter. And one was distance. Okay. But mainly as okay, mainly because okay, when we're going to as okay talk in details about amplitude, it's going to be as okay expressed in a relative unit, where that's going to be decibel. Well, here's okay, the main is okay, just ask you, do you know that okay, as an amplitude can be expressed in any of these units here as well? Whereas okay, for distance, it could be as okay, any unit of distance or length. Meter, centimeter, micrometer, mile, etc., etc., etc. So centimeter, yes, okay, that's going to be yes, okay for your distance. Pascals mean is okay, what we just said here. That could also be as okay, Newton per meter square. Well, okay, now what a Gauss is, I have no idea. And please keep in mind words, that's okay. You know, watts, that was okay as the unit for power. And you don't find power on this list here. Okay, so mainly it's okay, just pascals and centimeters. Question number 75. Now the maximum value of density of an acoustic wave is 16 pounds per, okay, a square inch. Okay. That, okay, may not make much sense. Okay. While the minimum density is 25, okay. Okay. Now we can mean it says, okay, let's do it this way. It may sound crazy, but we can say it's okay. Do something like this. And we can say it's okay, the maximum was 60 pounds, oopsie, per inch square. And we can say it's okay, the minimum is 20 pounds per inch square. Yeah. Now, girls, or remaining can say it's okay, the total difference between these two here is a total of, because that's okay, 40 pounds per inch square. Yeah, mainly is okay, we subtract. We can do it this way, say it's okay. How do we get that? Mainly is okay by saying 60 minus 20. Gives us a total of 40. Okay. But we can also say that this here is okay, the other one is okay, we can say it's okay, a peak to peak amplitude, where we mainly say it's okay, amplitude was going to say, okay, what value do we have here? Or what do we have here? So yes, okay, that's going to be okay, what will be the average of 40? That's going to divide that by 2. And that gives us, okay, as a total of, okay, as 20 pounds per square inch.
I have a question.
Yes, my dear.
This is one of the questions that I found difficulty with.
Mhm.
How would you know to subtract versus divide on this one?
Listen, dear. What did they give you? they gave you as okay the max value. Okay, the max value, which was 60, right? Clear? And they gave you as okay the minimum value, which was 20. Did you get that?
Yes.
Clear? Now, the difference between these two here is 40. Clear? But that's made as okay, going to be as okay, we can say, okay, the difference between the peak value and the trough value. Whereas, okay, when you look at the definition of amplitude, it says that is okay, as okay, from the average to the peak. This here had been the amplitude. Did that make sense?
Yes.
Okay. Then we can say it's okay, here's okay, the average is okay, it is 40. Whereas, okay, here, the difference between this to this is still just okay, 20. Okay, so either this is the amplitude or this is the amplitude. If you go as okay on to as okay the page where the chart of amplitude. And let me see. Let me give you the exact page, my dear. Yeah, actually it's okay. We'll find the answer for this one here. Where are we?
$27.
No,
Or 28.
on page 28.
Okay.
Or we can it's okay say 27 because okay, let's see, okay. Okay, so let's see. Okay, yeah. Second sentence and okay, it's amplitude. It is the difference between the maximum, which in this case here was 60, and the average or undisturbed value of an acoustic variable. Okay, so here, this middle line here, my dear, that is your average. So you can say, okay, the difference between the maximum and the average, that's going to be the amplitude of a wave. Or we can, on the other hand, also say, okay, the difference between the average and the minimum, this is going to be the amplitude of the wave. Clear? So what the medias, okay, just gave you here was to say, okay, this is the maximum, this is the minimum. Now we made as okay, you can say it's okay, we just calculated the range between the two. Clear? We calculated the range between the two, or we can say it's okay, the difference between the maximum and minimum. And then we say it's okay, we just divided that range into two because half of that range is going to be as on the maximum side, half of that range is going to be as okay on the minimum side. Okay, we can just play with some numbers here. We can just okay as, and maybe it's okay if we it's okay play with the numbers because we can say it's okay a similar question, not just different numbers. We can say it's okay our maximum. Or let's say it's okay that this is our wave. Clear? Okay. Now we can say it's okay. Now we just say change the maximum and says okay, we have a maximum of 75 pounds per square inch. And okay, that's on the other way. Yes, okay, on the other side, because it's okay, we have a minimum of, let's say, 25 pounds per square inch. Oh, let's work it out, and that's going to come. We can say 5 pounds. Clear? Did you get that, my dear?
Yes.
Now the question comes, that's okay. What is the range of your whole wave here? You mainly will say, yes, okay, that's going to, yes, okay, be 75, and we mean, it's okay, just subtract 5 from it.
Mhm.
So what do we get? 70. Now they say, it's okay, now they may, yes, okay, ask you, what is going to be, yes, okay, the amplitude of this, or the amplitude? Because that amplitude is okay, goes from the average, which is the mean, to the peak, or that's okay, from the mean or average to the bottom. So we can mean this as okay to get just okay what the worth of this one here or this one here is going to be. That's when we say as okay, we divide this whole thing here by 2. So here is okay, we can mean this as okay, that the value of either this one here or this one here is going to be as okay, 32 pounds per inch square.
Okay, thank you.
Did that make sense, my dear?
Yes.
Right, okay. But you can say as okay, now when we add these two up, but the whole that's okay thing is maybe that's okay hidden in the second sentence of amplitude that says that's okay. It is the difference between the maximum, which okay, and yes, okay, the average. The same apply as okay, it's also going to yes, okay, or it could be also say as okay, it's going to be as okay, the max, the difference between yes, okay, the minimum and the average. Okay, so okay. But had they asked, yes, okay, what is the average value here? Yes, okay, the average value here would had been okay. Okay, sorry. A total of 35 pounds per inch square. That would have been as okay, our average value. Okay. Yeah. But that's pretty much okay as how you would, yes, okay, solve a question like this. So when you take a wave, you will see it's okay from here to here. This, yeah, that's going to be, it's okay, what it says, okay, the peak to peak amplitude. Whereas, okay, the actual amplitude is either from here to here, or from here to here. Okay. Yeah, okay, because it's okay, this yes, okay, that was okay as the average. So the difference between is okay, the measurement or whatever is okay, acoustic variable along the average line to the peak or average to the bottom or trough or maximum and average, minimum and average. That difference is going to be as okay, the amplitude. So you were thrown off by as okay, not looking at, okay, not knowing that, okay, it was the average to peak and average to trough. Any questions, girls? Question 76. Now, the power of an ultrasound wave can be reported in which of the following units? No more than one answer may be correct. Okay. Okay, watts per square centimeter, that's going to, yes, okay. That is not the unit of power. That's going to be the unit of intensity. Because it becomes just, okay, watts per, or it becomes power per area. Decibel per centimeter. Now, that's going to be as okay, a unit that we will come across in chapter number 6. Clear? Watts is the answer for power. Clear? It can't be kilometer per kilogram per centimeter square. Okay. So the only unit for power is watts. Don't fall for the unit or option A, which I said. Watts per, yes, okay, any unit of distance squared, that becomes the intensity. So option A would have been the right answer had they asked, what's the unit for intensity? Question 77. Typically, as an ultrasound wave travels through the tissue, the power of the wave. And I already said that. We answered that same question as okay when we did amplitude. The power decreases as the wave travels through tissue. Just like amplitude decreases, just like intensity decreases. So it's pretty much okay. The same question asked about all of your 3 parameters, you can see. because we don't have, okay, that's another question again. Is it true or false to say that, yes, okay, the power can be changed by the sonographer? And that should be true. Just like, okay, as we could change the amplitude, we could change the intensity. Okay. Did that make sense? Question 79. Mathematically, it's okay when a number is squared. The number is there is multiplied by. Now, please, a number being squared. That does not mean that it is multiplied by 2. But that may mean that, okay, as it is multiplied by itself, or else, okay, 10 squared will become 10 times 10. 6 squared means 6 by 6. 3 squared means 3 times 3. 5 squared means 5 times 5. 4 squared means 4 times 4. So this becomes 100. This becomes 36. This becomes 9. This becomes 25. This becomes 16. Did that make sense? If you cube, I mean, it's okay, just mean that you multiply it, okay, as by itself. Right. A third time. So 10 raised to the power 3, a 10 cube becomes 1,000. That becomes 36 times 6, whatever that is. That becomes 3 plus 3 times 3 plus is 9 times 3 is 27. 5 times 5 is 25. Times 5 is 125. 4 times 4 times 4. 4 times 4 is 16 times 4 is 64. So yes, okay, what a jump. From 25 to 125. From 9 to 27, from 100 to 1,000. From 16 to, yes, okay, 64. Okay, so it is multiplied by itself. Any question goes? And when you go by 4, yes, okay, that's going to be multiplied by itself 4 times. Okay. Question number 80. The final amplitude of an acoustic wave. Now, clear. Okay, let's see. Because it's okay, the final amplitude of an acoustic wave is reduced to 1/2 its original volume. Is half of the original. or we can say, okay, the original world, yes, okay, could also have been, okay, as what we called earlier, okay, said was the initial. Clear? The final power is, no, the main is, okay, just say, the final power is of initial power. Now goes, what we knew was, or we can say, okay, power was directly proportional to amplitude squared. That means it says, okay, the initial power is halved. So initial power is halved, which needs to be squared. Which means it will mean that, okay, it's half multiplied by half, sorry, becomes 1/4. And that's going to be as, okay, the change in initial power. So the initial power is going to, as, okay, be 1/4. Okay, the final power is going to be as, okay, reduced. But the initial power is going to be reduced to 1/4. Okay. So if your initial power, for instance, okay, was 8, then the final power is going to, yes, okay, be 8 multiplied by 1/4, which becomes 2. But because it's, okay, the initial power could have been, the initial amplitude could have been 8 as well. But that is only as, okay, just halved. Right. Yeah, so that's okay. The final amplitude is going to just, okay, be 1 or 2 multiplied by 8, which means it's, okay, well, we had been 4. Yeah. And since none of the options that we were given, he said, okay, that the final power is going to be as, okay, 1/4 of the initial. That's why it's okay. That's okay. None of the answers are the same. Did you girls get that? Now here is, okay, yes. Who tried question number 81? Who have tried to do question 81? Okay. What have you guys been doing yesterday? Did anybody even try to look at it? Okay. God help you, girls. That's all I can say. Now, what do we have here? We are giving us, okay, the amplitude. And the main, yes, okay, just gives us, okay, we can say, okay, the initial amplitude, and we can say, okay, the final amplitude. We can say, okay, the initial amplitude is, okay, as 27 pascals. The final amplitude is 9 pascals. Clear? They just gave us, okay, as the same power. And says, okay, now the initial power is going to be 27 watts. And they ask us, okay, what is the final power? Now just look at the change in the amplitude first. It goes from 27 to 9. What does that mean? That your final power actually is, okay, sorry, the final amplitude. Your final amplitude is 1/3 of the initial amplitude. Did that make sense? So the amplitude is actually, okay, reduced to 1/3 of its initial. Now, the only thing that you need to do is square that. And what do you get? 1/9. And to find out, as okay, what your final power is going to be, you will multiply as, okay, your initial power by that. Because the power is also going to decrease because amplitude decreased. Did that make sense? So 27 multiplied by 1 divided by 9 is actually going to be 3. So your final power in this case is going to, okay, be 3 watts.
I have a question.
Yes, my dear.
Can't we just divide 27 by 9 and get 3? Or no, we're not supposed to do that?
No,
Okay.
because I can change the numbers. You could say it's okay, let's just change, it's okay, let's say it's okay that the amplitude here was 18. Let's say that our initial amplitude was 18 here, right? Okay. Okay, dear. The power, yes, okay, still remains the same, but they're still asking you, yes, okay, what is your final power? Okay, so these were the numbers that you were given. Where it means, yes, okay, we'll just read that, okay, yes. The amplitude of an acoustic wave decreases from 18 pascals to 9 pascals. Clear? Right, okay. If the initial power was 27 pascals, oh, sorry, watts, sorry. Right, okay. What is going to be as, okay, your final power? So they still ask you about the same. Now goes here, you can mean it's okay, just say, if you start off with $18, and only ended up with $9. You can mean it says, okay, the amount of money that you had is halved. So what we mean is, okay, so what happened in this case here then is that, okay, as your amplitude means, okay, because it goes from an initial of 18 to 9. What does that mean? That actually is okay, means that it is halved. Clear? Now, based on this information, they say, well, okay, this is your initial power. This is the value of your initial power. But they still ask, what is your final power? It comes down to the same. You will still have this, okay, because that change of the amplitude is always going to be squared to determine, yes, okay, what to do with the initial power. So yes, okay, here half squared is okay, going to mean half multiplied by half. Question 79 means, okay, just ask, yes, okay, what do you do with a number when it is squared? You multiply by itself. That becomes 1/4. Now here, my idea is, okay, what is that you will do then? So we still need to, okay, calculate, determine the final power is, okay, assuming that our initial power was 27 watts. So that's going to, yes, okay, those 27 watts multiply by 1/4.
I'm confused.
Why?
I don't get like how the equation is set up. Like the steps. If that makes sense.
Look here, girls. We said power was directly proportional to amplitude square, right? Just for a sec, girls. Just for a sec. Just don't, yes, okay, look at the m as, okay, raised to the power 2. Or the square here. For me, it's okay, just look here. What does this being directly proportional to this mean? That when power increases, the amplitude will increase. Likewise, we can also say that, okay, as if power decreases, amplitude decrease. Did that make sense?
Yeah.
Good. Okay. Now, what they mainly as okay say is that power is going to be as okay directly proportional to the amplitude square. Okay. Now, mainly says okay, being directly proportional. Say, well, okay, what does it mean to increase? That okay, yes, you might have started off with okay, yes, a low power, but that power gets greater, right? Which may mean that okay, as you started off with okay, as a small amplitude, and that amplitude of the wave is going to is okay increase. Whereas okay, as on the other hand, you say it's okay decreasing. What would that mean? That you start off with a great power, but that power is going to decrease, or you end up with a lesser power. Likewise, okay. The decrease actually means that okay, as you started off with a greater value and end up with a smaller value. Clear? Okay. Now, the thing here is okay, being is okay, saying that that's going to be squared. Which means we can say it's okay. If we, for instance, yes, okay, start off with a big value, we can say it's okay. An amplitude of 100. And let's just say that, okay, that amplitude decreases to, let's say, it's okay, 10. Did that make sense?
Yeah.
Right, okay. So what do you say now? Yes, okay, we can mean this as okay. This here is okay, that was our initial amplitude. Okay, this is the initial amplitude. This is the final amplitude. Okay, but we can actually say that, okay, as the amplitude decreased to 1/10, because the final amplitude is 1/10 of what we started off at. Did you get that?
Yeah.
Now we say, as okay, we can take any number. It doesn't really matter, my dear. We can say it's okay that we had, okay, as an initial power of 50 watts. Clear? And okay, as based on this change in the amplitude, they may ask us, okay, what is your final amplitude? Or what is, sorry, what's going to be as okay, your final power. Now that is where it's okay, your square to come in here. Because to determine the change in the power, you mean as okay, we'll say, okay, the amplitude is okay, decreased to 1/10. But we need to square this value here. Or find the square of this value to determine what we need to do with the initial power to find out what the final power is. So what does it mean? As okay, 1/10 squared actually is okay, is going to mean that 1/10 is going to, as okay, be multiplied by itself. Clear? This whole thing here actually means this. So 1/10 multiplied by 1/10 actually is okay, it becomes 1/100. So this is actually going to be as okay, the number that we will need to multiply as okay, use to find out, okay, as what our final power will be. So this actually is okay, we can say being this okay, this becomes the same as saying it's okay, 50 divided by 100. Clear? And now there are different ways that you can do that. You can say it's okay, this cuts this. So it becomes 5 divided by 10, which will be as okay, 0.5. So your final volt or okay, power is going to be as okay, half a volt.
So basically you have to square the
Change in amplitude to determine, yes, okay,
Right.
what to exactly.
Okay.
Okay. Or you can make up a cheat this way and say, yes, okay, the change in the power is going to be the square of change in amplitude. Did that make sense? So the change in the power is going to be equal to the change square of change in amplitude. The same will apply to the change in intensity. It's also going to be equal to the square of change in amplitude. Clear? Okay. Where we compare just P as okay, power and intensity, then you don't square. For that one, you do not square the change. When it comes to, yes, okay, determine the change in power based on the change in intensity, and vice versa. So the squaring only comes as, okay, you want just, okay, find the change in power related to change in intensity, amplitude, or change in intensity related to change in amplitude. Because at the end of everything goes, our equation, yes, okay, came out to this. Power was directly proportional to intensity, directly proportional to amplitude squared. There I may just say it's okay. This change here is going to be as okay equal to this time this. And this time this. So the change in amplitude is going to be just okay greater when it comes to the change in the intensity and the change in power. Likewise, it's okay if we say it's okay decrease. So that we have okay a greater change in power compared to change in intense amplitude, greater change in intensity compared to amplitude. Where you can say it's okay, the change between power and intensity will be the same. That is okay. If this doubles, then this double. If power is reduced to half, intensity will also be reduced to half. And goes not to be an a-hole, but right now I'm practically PISSED. And I have the right to be PISSED. Because I have repeatedly, yes, okay, asked you girls. And nobody has said anything. Practically speaking, I'm not supposed to do these questions for you. So that's how it goes. So you can, yes, okay, use this cheat, yes, okay. This cheat here. Right? Where you can mainly say, okay, let's just say that, okay, yes, amplitude is doubled. Intensity is okay, will increase 4 times. And so will power increase 4 times. We can say it's okay, amplitude increases 3 times. Now that may mean that, okay, as your power and amplitude and intensity will increase 9 times. That's usually, it's okay, the max that you will get to. Whereas, okay, we can say it's okay if amplitude is reduced to half. Intensity will, it's okay, reduced to 1/4. And so will the power reduce to 1/4. You, on the other hand, can say it's okay if amplitude is reduced to, yes, okay, 1/3. Then power will reduce to, yes, okay, or intensity will reduce to 1/9, and so will power reduce to 1/9. But what does it mean to reduce? That the final product, the final number that you have is lesser than what you started with, right? If something reduces, that means that you are left with less than what you started with, right? Where something increases, that means that you have more than what you started with, right? That's not even physics, because that's just common sense. Now, not even common sense, that's regular English. So that's how you do the math. That's the worst math that you can get. Okay. So yes, okay, you can mainly, yes, okay, just use this cheat here. Clear? And how do we get 1/9 here? Why do we get 1/9 here? That's me, it's okay, just 1/3 being squared. We can go to another extreme and say, okay, one or 4th, or reduced to 1/4. Now, I mean that, okay, this is going to be, okay, reduced to this 1/16. So is this. Whereas, okay, if amplitude is, okay, increases 4 times, power and intensity is going to, yes, okay, increase 16 times. Any questions? So it could be any numbers. It could be any numbers. Okay, so in this question here, what we mean, yes, okay, just saw that the power, yes, okay, the amplitude reduced to 1/3. Clear? Okay, what would that mean? That would mainly mean that, okay, as your power is going to reduce to 1/9 of the initial. Clear? Okay. It could have been asking, yes, okay, of, okay, as the final intensity rather than power. The final intensity would still have been 1/9 of the initial. Clear? So when if power is halved, intensity halves. Clear? Provided that, okay, the area is constant. Because we established that relationship by, okay, keeping area constant. Clear? Question 9282. And you can go on. You can say, that's okay, what about 1/5 or 5 times? Then, okay, it's going to be, okay, just be, okay, the square of 5, which is 25 times. 25 times. 1/5. 1/25. 1/25. But it's probably not going to go, yes, okay, to those extremes. Most likely, that's okay, the main one that you will see is, okay, is something is doubled or something is tripled. Something is halved or something is, yes, okay, 1/3. Did you ladies get that? So something, yes, okay, is tripled, is going to, yes, okay, these two power and intensity is going to be increased 9 times. So in the same question, yes, okay, here if they say, well, okay, if it was the other way around, okay, we can say, yes, okay, just flip it around and say, yes, okay, the amplitude is not decreased, it is increased. Okay, so we have, okay, as the initial was, let's say, yes, okay, 9 pascals. And we have, okay, as the final amplitude is, we can say it's, okay, 27 pascals. What do you have now? You can mainly say, okay, that the final is greater than the initial, right? Okay, what does that mean? That it actually is, okay, has increased. You just need to, yes, okay, determine how many times. So 27 is 3 times 9. So it actually has increased 3 times. Now you can take up any power, you can take up an amplitude. It doesn't really, intensity. It doesn't really matter. We can say, okay, that if the intensity, for instance, now our initial intensity is, okay, maybe 27, that's, okay, watts per centimeter square. Clear, and they're still asking us, okay, yes, what is your final intensity? Now, before getting answers, okay, what you do with this final power here, we says, okay, power and temperature increase twice. But what we need to do means, okay, because that this needs to be squared. So what's the change? This is going to become 3 times 3, which equals 9. And that's pretty much okay. That's what we will multiply your final is okay initial power with to get this number. So the product of 27 multiplied by 9 with the unit watts per centimeter squared is going to be okay your final intensity.
Just to clarify, we're multiplying 27 by 9, and that will give us the answer.
Yes,
All right.
but then you also have to make sure that you use the right unit, right?
So when you're finding the intensity, you multiply. After you square, you multiply.
No, because we only multiply because it increased. It increased. Or you can say it's okay, you multiply by this number. Or had it been decreased, my dear, then you multiply by this. And multiplying by 1/9 is actually is okay the same as dividing by 9. But it's okay, here we are going to multiply mainly, it's okay because we had an increase.
So if we have a decrease, that's when we,
Then you can say, okay, if it had been decreased, you can say, okay, by 9, you can say, okay, then you multiply by 1/9.
oh, okay.
But the 1/9 is okay. This actually is okay. Once you go into fraction, it automatically is okay, becomes negative.
Okay,
By negative, because negative means that okay, is that you decrease. But saying it's okay, multiply by 1/9 is actually that's okay, the same as dividing by 9. You can take any number, my dear, and multiply by 1/9, or multiply by any fraction, or say, well, okay, let me just divide it by the denominator. It's the same. Question number 82. Now, the intensity of an ultrasound beam is defined as the dash in the beam dashed by the beam of the beam. Now, what is intensity? It is going to be defined as the beam in the beam, or the dash in the beam. That is going to, yes, okay, be the power in the beam. Right. Divided by area of the beam. Or if you just look at it, saying that intensity made us, okay, just was power by area. Which means, okay, just for me that, okay, as you will divide the power by the area. Now we probably, as okay, already have said that these two here, okay, are directly proportional. And intensity and area are inversely proportional. Here we mean is okay, so that's because okay, if you kept the power constant. Whereas for this one here is okay, that's where we keep the area constant. But changing both power and area is going to just okay have their own changes on the intensity. Did you guys get that?
Yeah.
Good. So if something said, okay, the area is constant and power increases, what's going to happen to the intensity? Well, okay, that will also increase. If power is constant and area increases, what's going to happen to the intensity? It will decrease. If both area and power changes, what's going to happen to the intensity? Well, that is going to be then dependent upon, as okay, what is going to be, as okay, the change in power and area. How does power change? How does area change? That's going to, as okay, determine what's going to happen to your intensity. So question 83. As a sound travels through the body, what typically happens to the intensity of the wave? We have already, yes, okay, done that in context to, yes, okay, amplitude and power. And I say, yes, okay, we can kill one bird with, okay, 3 birds with 1 stone. They all suffer the same fate. So there, that's okay, here is okay, the intensity will also decrease. Just like power did, just like amplitude did. Now, what is the unit of intensity? No, yes, okay. That was mean, yes, okay, that's going to be, yes, okay, the unit of power or unit of area, which becomes watt or any unit of distance squared. Okay. It can be milliwatt. It can also be kilowatt. It can also be megawatt. It can be as okay, likewise, okay, a bigger or smaller unit of distance or area. Okay. But for the distance, that's okay, the unit of distance, it has to be squared to become area. But it can be watt per meter, it can be watt per millimeter, it can be watt per micrometer. Squared, sorry. Clear? So either this up here is okay, can be fractioned or multiplied. Likewise, can this here is okay, be fractioned or multiplied. It is still going to just okay, be considered a unit of intensity. So don't come to me and say, well, okay, Mike, the book says that the unit of intensity is watts per centimeter square. Just because yes, okay, the option is kilowatt per micrometer square. That is still a unit of intensity. There's going to be a hell of a boom or a blast of intensity, but it's still a unit of intensity because what is it? It's still a unit of power per unit of area. So that means, okay, just came out right off the definition. Clear? Question 85. Now we already have answered this question here as well when we did power and amplitude. Right? It's true. Okay. That, okay, yes. That the operator, the sonographer, and okay, has changed the power or intensity of the ultrasound beam. Likewise, question 86, we already answered this one here for the power and amplitude as well. Okay, what determines the initial intensity? Now, please, guys, it's the initial that's going to be source. Clear? Okay. Okay. Had it been final intensity, the best answer would be what your initial intensity was and okay, the medium. Clear? Or you can say, okay, what determines that, okay, the initial intensity is still the source. Question 87. What determines the intensity of a sound wave after it has traveled through the body? Now, this is okay, what I just said. Okay, so this is okay, just a little bit hanky-panky way of asking, okay, what is your final intensity? Or what's going to determine your final intensity? And what will be your final intensity? Or what's going to determine that? Well, we can answer, okay, just look at our answers here. It's going to be both. Source, which determines, okay, your initial intensity and the medium. Why? Because we say, well, okay, not just intensity, even as okay, your power, even your amplitude decreases. They will decrease as they travel through the body. That is clearly written in the second paragraphs of all these three bigness parameters here when it comes to the determined by. Did you girls get that?
Yes.
Anybody has any question? Okay, so here it's okay, just saying it's okay, just wording it after it has traveled through the body. So it's just asking what is the final intensity. Now, what are the unit of the transmitted intensity? It doesn't really matter. It doesn't really matter whether it says transmitted intensity, reflected intensity, reduced intensity, blah, 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 blah. The unit of intensity is the unit of intensity. So it's going to remain the same. Clear? Okay. It doesn't even matter if it has said as, okay, what is the unit of reduced power? Power is still going to be reduced by watts, or increased power, or reflected power, or whatever. It's going to be in watts or milliwatts, kilowatts, gigawatts, whatsoever. Okay, so it's still going to be as okay that watt per centimeter square, or milliwatt per centimeter square, or milliwatt per kilometer square, or something like that, as long as it's a unit of power by unit of area. Okay, girlies. Question 89. Who have tried to answer question 89? Who have issues with finding why the answer it is what it is? Is your hand, okay. Did your hand went down for that last one part too? No. Just asking you. Look. The information is in the question. So the main is, okay, what happens to the power of an ultrasound beam? Let's see. Okay, what happens to the power in an ultrasound beam? No, when it happens, okay. What happens when the power in an ultrasound beam is unchanged? So we can say, okay, power and power is the same. We can say, okay, any number, 20 watts and 20 watts, because it says, okay, that the power in the beam is the same. Which means that, okay, I says 20 watts and 20 watts. Okay. Okay. And at the same time, yes, okay, the area doubles. So we may say, okay, first we had, let's say, as okay, an area of 10. But the change in the area going to is okay, that will double, which make it 20 centimeters square. Now, here's that there's no magic in the numbers. You can put any numbers. Okay. Just make sure that, okay, your powers are the same and okay, as the area is double. So what is our intensity here? It's going to be the power divided by the area, where it becomes just okay 2 watts per centimeter square. Whereas that's okay when we calculate the area, it's okay intensity here is going to be 20 by 20. And we have it's okay 1 watt per centimeter square. So just because okay we double the area, the intensity is halved. Did that make sense? Did that make sense? Where are you?
It does.
It does. Okay. Good.
It's the wording that tricks me up, so that's why.
Sometime, yes. Okay. Yes, a little bit unfortunate. Okay, some kind of okay. Sometimes that's okay. The wording of these questions here are not as straightforward as we had wished them to be. Let's just look at question number 90. Now, what happens to the acoustic beam's intensity when the power of the beam increases by 25%? And the cross-section area of the beam remains the same. So here we can say it's okay, area and area is the same. We can say it's okay, overhead beam 20 centimeters and 20 centimeters square, right? Okay. Area remains the same. Whereas, okay, as on the other hand, we can say it's okay, power. Okay. We can say it's okay that we had, okay, as an initial power, or let's say it's okay, 100 watts. Okay. But that power is okay, is going to just okay, increase 25%. Which means that's okay, just for me that okay, as our final power is going to be as okay, 125 watts. Okay, but guys, here you really don't need to do the actual math. They say, well, okay, area is constant. Okay, so since power increases 25%, you just need to know, okay, what is the relationship between power and intensity? That is also okay, going to increase the same 25% because the area is constant. So that is straightforward. Right?
Sir, can we get a break, please?
You will get your break when you do. Okay. See you ladies back at, should I say 12:45? Fuel up.
Okay.
Take care, girls. Okay, girls, welcome back. Hey. Now, girls. Is this what we'll be doing now? So if it says if the power of a beam is tripled, right? Okay. While the cross section remains the same. I guess okay, area is same as area, whatever. But the power increases 3 times, then the intensity is also going to increase 3 times. Clear? That's your answer. You can do it this way and say it's okay, power was, because it's okay, initial. We can say final. We can also say it's okay, area is the same, right? Okay, area remains the same. So we can say it's okay, any area. We can say it's okay, 2 centimeters square. 2 centimeters square. Now we can take any initial power and say it's okay, that had been 2 watts. But the change that happens is that it increases 3 times, which may mean that, okay, as the final power is again going to be 6 watts over 2 centimeters. Now you can just say, okay, say what was our intensity here? That was going to be, okay, those 2 watts per 2 centimeters square. But okay, the intensity becomes 1 watt per centimeter square. Where over here is okay, your intensity became 6 watts per 2 centimeters square. Which becomes just okay, a total intensity of, final intensity of 3 watts per centimeter square. Because it becomes 3. So 3 is 3 times 1. So intensity is increased 3 times. Did you girls get that?
Yeah.
Right, okay, so here is okay, there's no squaring, there's no cubing or anything. Here it means okay, just directly. Okay. Question 94. Now they made it okay, say that yes, the amplitude is increased. Which of the following, so the mean is okay, are given us a list of, okay, which of the following is most likely as okay going to as okay remain unchanged. And what the mean is okay mean by as okay unchanged, it means okay just say as okay will not change. Now we can mainly as okay look at power. Now we know that okay, as if amplitude increases, that power will also increase. So that is not what they were looking for. They're asking, okay, which of the following will not change? Now, when they say frequency, you can increase the amplitude as much as you want to. The frequency will not change. Okay, girls? Because frequency and amplitude is okay, we're not related. That's pretty much okay. You can say it's okay, the explanation behind it. Likewise, okay, as you can change the amplitude as much as you want to. That is not going to, as okay, change the period either. Because period and amplitude was not related, just like period and frequency was not related. Period and frequency and amplitude were not related. Whereas, okay, on the other hand, we can say, as okay, intensity. If intensity is okay, if amplitude is increased, you will also have as okay an increase in the intensity. But that was not what they asked about. They said, it's okay, which of these does not change? Had they asked you which of the following change when we change the amplitude, then the answers would have been, that's okay, power will change, intensity will change. Clear? They might have said, it's okay, if there's okay, if an option here is okay, we're also have been wavelength. Now goes, just for the hell's sake, the wavelength will not change, even if the amplitude changes. Is that clear? Likewise, your propagation speed will not change or not increase or decrease if the amplitude increased. Okay, now just keep in mind here, it's okay, that since they asked that, okay, they say that the amplitude increased, and had to say, okay, which of the following will decrease? Then this will mean, yes, okay, that will mean I come over here. Because when amplitude increase, power increases. When amplitude increase, intensity increase. Clear? So I had said that, okay, yes, if amplitude increases, which of the following does not increase? Then, okay, yes, power and intensity will also be as okay, we're here. The call then is okay. Did that make sense?
Yeah.
Good. Question number 95. A sonographer adjusts the power output power of an of a wave emitted by the transducer, which of the following also changes. Now, yes, okay, it just says, okay, that we adjust power. Now, what adjusting means, yes, okay, that can mean that you either as okay increase or decrease. Clear? Okay. Now goes again as okay, the first two options, which is pulse repetition period and PRF, where PRF is just okay as an abbreviation for as okay, what we will call pulse repetition frequency. Those are two things that we will talk about as okay in chapter number 4. That will be Monday. Okay. But they are not going to be as okay be changed as okay affected by as okay changing of the power. But they're mainly given here as okay, assuming that okay we have done the whole book before going to these questions here. Propagation speed is not going to change if you change the power. That is increasing the power, decreasing the power. The only thing that will change of the options here is intensity. So if we increase the power, the intensity will increase. If we decrease the power, the intensity will decrease. Okay. Your propagation speed is going to remain the same, provided okay that the tissue is the same, but that's not what they're asking here. Okay. Did you ladies get that? Now the next series of questions are mainly okay about the wavelength. Who have tried to yes, okay, answer from question 96 all the way to 110? Good. Good. Some more hands are up now. Okay, good. Any questions that you have any issues with? Or were these questions here more straightforward? Okay. Let's just try to okay, quickly browse through them. So wavelength of a cycle and an ultrasound wave can be reported by which units? Now, I hope everybody is okay, should be clear on that one right now. Wavelength is mainly is okay, just the unit of length or distance. Clear? It is not going to be cubed. That unit of distance or length is not going to be squared either. Clear? Straightforward as okay, unit of length or distance. Centimeter, millimeters, so on, so on, so on. Clear? Did you guys get that?
Yeah.
Question 97. Wavelength of an ultrasonic wave is determined by. Now that was what you had in a hint box. Both source, which was going to, okay, in this case, it was going to be the transducer and medium. Clear? That's okay, it actually is okay, the wavelength actually changes, that's okay because of the changing speed. So that was the only one where it was both source and medium that were determining that's okay, your wavelength. Question 97 or 98. Now, God, you already had this question that's okay here in your chapter review or the questions of the chapter itself. But mainly that's okay, just says, okay, yes, okay, where is the wavelength? If the frequency of the transducer is 2 megahertz, and okay, as we are talking of soft tissue. So since that's okay, we say soft tissue, that's where it's okay. This will be the number divided by, it's okay, the frequency. And I told you guys, that's okay, it's going to be as okay, making your life easier. If you just know that, okay, 1.54 divided by 2 is equal to 0.77. And then yes, okay, yes, okay. This would be in millimeters. So that would be, yes, okay, the wavelength of the sound wave in soft tissue. Of it when the yes, okay, when scanning it with a transducer of a 2 megahertz frequency. Did you guys get that? So when I told you, yes, okay, girls, yes, okay, make sure that you remember this formula here. The wavelength is divided by, okay, is equal to, yes, okay, 1.54 divided by frequency. Okay, girls, just give me 1 second. Any questions? Any questions, girls? So you can be asked of any frequency, and okay, as you should just put that frequency into the equation, right? Okay. Yeah. Okay. Let's see, ladies. Question 99, what a number. Which of the following best, okay, yes, which of the following term best describes the relationship between frequency and wavelength for a sound wave traveling in soft tissue? Now just look at the equation here. It's okay, wavelength is okay as a constant number divided by frequency. That mainly says, okay, any factor or number that you just, okay, calculate is always going to be as, okay, reciprocal to the denominator, which in this case is, okay, not reciprocal, sorry, inversely proportional to the denominator of the equation. Okay. So please go as, okay, your frequency is only as, okay, inversely proportional to the wavelength, which mainly says, okay, the greater the wavelength, oh, sorry, the greater the frequency, the lower the wavelength. Because you went from 2 megahertz to 3 megahertz, the wavelength will decrease. Okay. You went from 3 megahertz to, let's say, it's okay, 15 megahertz. You divide it by a bigger number, okay, as your wavelength will decrease. So that means, okay, it just makes it inversely proportional. Okay. Please keep in mind, wavelength and frequency are not reciprocal. That relationship only applies to your wavelength and, no, sorry, period and frequency. Okay. Now here they are giving us, okay, some information. Okay. So what they mainly say is, okay, we have two pulses traveling through the same medium. So we can say, okay, what's going to be as okay the point that we get from the same medium? Yes, okay, the same medium is okay. What would that mean? That would mean same speed, right? Okay, but we have yes, okay, two transducers that scan the same medium because it's okay, transducer A, and we can go on and say, yes, okay, what is transducer B? We can say transducer A, that is okay, that's 2 megahertz. B here is okay, let's say it's okay, 10 megahertz. Did that make sense? Now there's okay, this is our information that we have. Okay. They didn't give you okay, this information here directly, that's indirectly between okay, same medium. So question number 1 says, which of the following wave here has the higher period? That mainly mean that okay, as you need to know the relationship between frequency and period. Now they say it's okay, the higher period, which is inversely proportional or reciprocal to the frequency, meaning as okay, well, I was indirectly asking which is going to be lower frequency, 2 megahertz. Did that make sense? Now question number 101. And it mainly says, okay, which pulse has the longer wavelength? And we already know that, okay, as now we say longer wavelength, we already know that, okay, wavelength is inversely proportional to frequency. So greater wavelength will be again, as okay, be lower frequency, so it's okay, 2 megahertz. Did that make sense? Whichever tissue, we can say, okay, the tissue was okay, soft tissue. So it's okay, yes, okay, that frequency we're having is okay, 1.54 millimeter. Over here, we had been 0.154 millimeter, which means okay, will be as okay, a shorter wavelength because of a higher frequency. Okay, so here it's going to be 0.07. Sorry. Question number 102. Now, which of these two transducers here has the lower propagation speed? Now, that's where they tricked you because they didn't mention anything about the speed in the question directly. Directly they didn't, but indirectly they did because they say, well, okay, it's the same medium. So since it's the same medium, it's going to just, okay, be the same speed. So speed here is going to be equal to speed here. Did that make sense? Did you guys get that? Question 103. Which pulse has the lowest power? Clear. Now, practically, at least from the information that we have in the question, that's really not something that we can determine. This transducer here could have a low frequency but a great power. This frequency or this transducer could have, has a higher frequency but have a lower power. They can have different frequencies at the same power. We don't know. Why? First of all, no information is given in the question. Second of all, frequency is not related to power. So here's that can't be determined. Clear? Did that make sense?
Yeah.
Good. Girls, please try to verbally respond because I can't see you, so if you raise your hands or something like that. Okay. Question. Okay, question 104. Now again, yes, girls, sorry. This one here is only going to, yes, make sense once we have done chapter OMG. That's going to be chapter 10. What a spatial pulse land is going to be. Okay. But again, yes, that can't be determined either. Okay. Because they're going to be, yes, other balls on the soup to determine, yes, what a spatial pulse length is. Not just the frequency. We will need more information about this, the pulse itself. Question number 105. True or false? The lower frequencies, the lower frequency sound wave creates higher quality image with greater details. That's false. And again, yes, something that will come as become as we can say more clear as once we talk about as things such as spatial pulse length. Although as I already as briefly mentioned that as the higher frequency gives us as better diagnostic images. So yes, here they just ask us the opposite. Is a lower frequency transducer going to give us better images? No, lower frequencies actually is give us because it's worse imaging. Okay. So something that's going to just become more obvious as as we proceed through the course. Question 106. What is the wavelength of the 10 megahertz ultrasound in soft tissue? Now they may just just said this one here. And they specify that you should say, this was our 10 megahertz transducer. What is going to be as its wavelength? If this 10 megahertz transducer here is was used to scan soft tissue, where we mean is put our standard 1.54. Where as the ultra wave, it's going to be as 1.54 divided by 10 is going to be 0.154. And as this unit here is going to be millimeters. Did you ladies get that? Yeah, Did you girls get that? Okay, good. Thank you. Okay, we have another set of questions here. So, two waves Now we have two waves, and we can say, okay, let's just do it this way. We can say A and B, or one or two, it doesn't really matter. Okay, now what do we have here? We can say, okay, the frequencies, one is 5 megahertz, and the other one here is 5 kilohertz. Travel through soft tissue. So we can mean it as, okay, the tissue is soft tissue. Yeah, okay. Are the following statements true or false? Now let's see. The period of the 5 megahertz, let's see, okay. The period of the 5 megahertz wave is less than the period of the 5 kilohertz. And that's true, because we can still say as, okay, 1.54. No, that's okay. Here we divided by, and just keep in mind, goes that, okay, it's going to be 5 megahertz. Clear? Okay, where remaining says, okay, in this instance here, it's okay, the wavelength is going to be as, okay, we can say it's okay, 0.3 millimeters. Whereas here we say as, okay, the soft tissue is, okay, 1.54. Okay. But 5 kilohertz, actually it's going to as, okay, be lower value. So you actually, that's okay, end up with because there's okay, wavelength, which will be something like this. Now you may say, well, okay, we calculated the wavelength, but then you just should know that, okay, yes, wavelength is directly proportional to period. Did you guys get that?
Yeah.
Okay. So 0.3 millimeters is less than 300 meters. Or you can say, okay, 30 cents is less than $300, right? Although it's okay, we calculate the wavelength here. Or we can mainly say, okay, just as we said in the, okay, the greater the frequency, lower the period. Lower period, a lower frequency, greater period, whichever way. I probably shouldn't have done this calculation here, because that's probably okay. It's me is okay, they're directly asking, okay, yes, what's the relationship between period and wavelength? Or frequency, sorry. Okay. Okay. The wavelength of the 5 megahertz wave is greater than the wavelength of the 5 kilohertz wavelength. Yeah, okay, we just is okay, did that. But here to say, is this wavelength here greater than this one over here? No. The lower frequency is okay, is greater than the higher frequency. Yeah. The ultrasound wave travels much faster than the audible wave. Now just keep in mind, okay, this 5 kilohertz, yes, okay, that was the audible wave. This one here is okay, is the ultrasound. Now they may ask, yes, okay, is this ultrasound is okay traveling at a greater speed than this one here? No, because the tissue is the same. It says in the statement that okay has traveled through soft tissue. Both waves have traveled through soft tissue, which means okay will cause that okay as the speed at which these two sound waves here will travel will be the same. Okay, or the speed will be the same as okay 1.54 millimeters per meters per second. Sorry. I'm sorry, 1,540 meters per second, or 1.54 is okay millimeters per microsecond. I mean, because the tissue is the same, the frequency, the wavelength, blah, 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 period, power, intensity, all these doesn't really make any difference. Okay, so since question 109 is false, they just ask the same question in another way, oppositely in okay as in another wording. It's okay in question 110. And says, okay, is it true to say that okay, both the 5 megahertz and 5 kilohertz waves travel at similar speeds through the medium? Yes, that's true, because the medium was the same. Did that make sense, girls?
Yes.
Good. Let's look at the next one, which is mainly as okay, our set, which is going to be talking about is okay, our propagation speed. Now here the main is okay, say an ultrasound is okay, propagates from soft tissue through a mass. So what we mean is okay, we'll say is okay that we have here is going to be okay first. Is going to be okay soft tissue. Okay, so from soft tissue is okay through a mass. Clear? Okay. Now we already as okay then know that okay yes, and the mean is okay say the sound's propagation speed in the mass is 1,575 meters per second. Just for the safety sake, although yes, okay, it is not given in the question, but that's what I said. Just make sure that you know that this is 1,540 meters per second. Clear? Okay. How do we know that? Because okay, it says that it is a soft tissue. Now the frequency increase, I'll say now, is it going to be true to say that the frequency increases as the wave travels through the mass? Which means it says, okay, would you have a higher frequency here and a lower frequency here? No. As a matter of fact, the frequency will remain unchanged. Because okay, that would mean it's okay, determined by the transducer itself. Clear? If it was a 10 megahertz, it's going to remain 10 megahertz as it travels through this soft tissue and through this mass. Did you girls get that?
Yeah.
Good. Question number 112. Is it true to say that the period of the sound wave decreases as it travels through the mass? No. Because period again is okay, or something is okay, that primarily is okay, was determined by the transducer. You can say it's okay here. It was going to be 1 microsecond. So it's still going to be wrong to say that, okay, yes, the period increases. Or you have, okay, a lower period in the soft tissue and a higher period in the mass. Just like it was wrong to say that, okay, as the wavelength, no, sorry, frequency changes is that greater in the mass and lesser in the tissue, soft tissue. Clear? Now comes what I have been saying about it, okay, relationship between period and wavelength. So is it true to say that the wavelength increases as it passes through the mass? Which means, okay, we mean that, okay, here we have a lesser wavelength. And yes, okay, that is true. Because what I said was that, okay, yes, an increase in speed is going to increase the wavelength. Where, okay, as vice versa, a decrease in speed will decrease the wavelength. And what is it that we see here? That the speed of sound in the soft tissue is just 1,540 meters per second. Whereas in the mass, that's okay, it travels. At least in this mass, yes, okay, it travels at a higher speed, which is 1,575 meters per second. So increase by as okay, 35 meters per second. And that change in the speed actually will cause the, okay, as here is okay, the wavelength will be okay, as slightly greater than there was in the soft tissue. Did you girls get that? But as I said, it's the wavelength, okay, it's the speed that will affect the wavelength and not the wavelength that will affect the speed. Did everybody get that one? Good. Question 114. So it is true to say that the power of the wave increases as it travels through the mass? No. That would be false. As a matter of fact, that's okay, what the actually says, okay, if this was okay as where our transducer was, and it produces a wave that first travels through the soft tissue, and then okay, as then travels as okay after passing through the soft tissue, gets to the mass. Here in the mass, we would actually as okay have a relatively as okay reduced power. Right? Okay. Okay. But how much? Beep, 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 that's really not factors that we can as okay determine here. Okay, but had they asked it, had to ask, okay, as a question, and we say, is it true to say that, okay, as the power will be greater in the soft tissue than in the mass? That would have been true. Or do you say, how in the hell am I going to know that? It's from the question. Because it says an ultrasound wave propagates from a soft tissue through a mass. Did you girls get that? So what does it mean to propagate from? Proceed. So it passed through me and then it went through SOK, another mass, or other tissue, right? Okay. So a lot of things may not be directly asked, but you have to pick up some clues. Yeah. Let's go on to the next one, unless somebody have a question. Good. OMG, now we have 3 identical waves. Or we can say, okay, 3 waves, OMG. So we can say, okay, they even give us different medias. So we can say it's okay, wood. We can say brick. And we can say fat. Now, girls, what do they say here? 3 sound wave with identical frequencies of 3 megahertz. Okay. Have powers of 2, 5, and 15. And okay, what we have here is milliwatts. Okay. Now let's see. They all travel through, yes, okay, 3 medias. Okay, that's going to be, yes, okay. So all waves, that's okay. With this power frequency, and this power frequency, it travels through, is okay, yes, okay. Different medias. Okay. So, okay, this part, first part, your power was, or you can say, okay, so we can say the medias that we have are generally going to be, yes, okay. Media is going to be, yes, okay. Fat, brick, and wood. Okay. With identical thickness of 5 centimeters. So, okay, it says, okay. Thickness here is okay as 5 centimeters. Are the following 3 statements true or false? Now, the waves travel through all different media at the same speed since they have the same frequencies. And that's false. Because each medium here is okay is going to have its own speed. So the speed of fat is not equal to the speed of a brick, which is not going to be equal to the speed of sound and wood, because they were different medias. Okay. The sound traveled through all different media at different speed because of the waves have different powers. Now we can say, okay, that first part of the question is true. That they travel through, yes, okay, the different medias at different speed. But is that different speed due to, yes, okay, the different powers? No. That's just because of the different nature of the media. Did you girls get that? So Harry says, okay, that they will travel through different medias because at different speeds through the different medias because they are different medias. That never have been true. But it's not just, okay, due to the different powers that the speed travels at, different speed through the medium. Because power and speed are not related, pretty much. Is it going to be true to say that the waves travel through all three media at different speeds because the media are different? Yes, okay, I just answered that one, right? Yes, that's the reason that they travel through, yes, okay, different speeds at through the different medias because they are different medias. And you can mainly, yes, okay, see here, yes, okay, this information here, that is mainly, yes, okay, just BS. Not really. Because, okay, when we come to some later chapters, you will, yes, okay, come across that, okay, yes, something about frequency and all that, yes, okay, maybe, sorry, yes, okay, related to thickness. But not thickness of tissues and something like that. Okay, so that was me, yes, okay, just some unnecessary, yes, okay, extra information given there. In this case, yes, okay, prime, yes, okay, just to throw you off. Question number, ting, 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 118. Okay, buddy. Okay, we can say propagation speed can be correctly recorded in with which of the following units? Because it's all of them. Because speed, as long as, okay, as it is a unit of distance or length or time. So miles per hour, that's what you do in your car. You can say, okay, millimeters per millisecond. Okay, kilometers per second. Okay. You're going to be speeding if you travel kilometers per second and inches per year. That's okay, that is some slowy bowie. But anyways, all of them, yes, okay, since they are main, yes, okay, just unit of distance per year. Or unit of distance, sorry, per time, sorry. Okay. Okay, guys, please just disregard question 119. Okay. That will become, yes, okay, we can say, yes, okay, a little bit more clear, yes, okay, once we have talked about, yes, okay, continuous wave versus pulse wave. Okay. And to be more, yes, okay, factor, okay, we can say, okay, duty factor. That's going to be chapter number 4. So we can say, it's okay, 120. what is the best estimate for the sound of distance can travel in soft tissue in 1 second? Now, we mainly said it already. That, okay, yes, it means, okay, saying per second. And we say that, okay, yes, that was going to, yes, okay, be 1,540 meters per second. And they already have, okay, specified the tissue here, which was, okay, yes, soft tissue. And what I said that, okay, that 1,540 meters is approximately, okay, 1.5 kilometer, which is equal to approximately, as okay, one mile. Okay. So even if you are driving, you can say it's okay, 60 miles a second or 60 miles an hour. The distance that it takes you 1 minute to travel in your car is going to take the sound 1 second in soft tissue. So you're going to be super speeding. You're going to be traveling at the speed of sound in soft tissue. Okay, girls? Question 121. True or false? Shorter wavelength create a higher. Yeah, what the hell? Okay. Shorter wavelengths. Again, yes, okay. Now I can make that, okay, that's short wavelength, okay. That's again, yes, okay, your spatial pulse length. So please disregard this one here. Okay, but it's going to be true. Okay, and it's going to, yes, okay, be short spatial pulse length, and okay, yes, greater ERs. The wavelength of an acoustic wave is shorter when it is pulsed rather than, and again, it's okay. Continuous versus pulse wave. Again, it's okay. Omit this one here, girls. 22. The speed of sound traveling through bone is dash soft tissue. Okay. And that's why I say it's okay. That it was greater in the bone and less in soft tissue. So when I told you guys, that's okay to remember that list. Where okay, as if you went from low to high, where bone was down here, soft tissue is somewhere here. Okay. Okay. That's mainly it's okay what they just asked about here. Now, just on the other hand, is okay, compared to soft tissue, the speed of an acoustic wave through lung is, well, okay, ladies, lung was up here. So, okay, the speed of sound in soft tissue. Okay, comparing the speed of soft tissue compared to soft tissue, that's okay, the speed of an acoustic wave through lung is, the speed of lung in, or the speed of sound in lung is lesser than it is in soft tissue, because soft tissue have a greater speed. Okay, now, although as like I say, as okay, this what is the best, okay, what is the best estimate for as okay, speed of sound in a tendon? Now just remember, guys, okay, your tendon is going to be as okay somewhere down here. We already know that this value is okay, was this much. So it can't be one option A because there would be somewhere here. It can't be option 2 because option 2 would have been that of soft tissue. Clear? It is going to be option C. And it can't be option 4 because, okay, even this value, 5,400 meters per second, is even greater than the maximum speed of sound in any medium or tissue, for instance. Clear? Because your bone speed was 5,000, that's okay, 4,000 meters per second. Did you girls get that? Okay, girls? Now the rest of the remaining couple of questions, please try to just, okay, do those over the weekend. And if you have any questions, we can take them briefly up on Monday. Or otherwise, no, not Monday, sorry, Tuesday, sorry. Okay? Otherwise, not otherwise, we have to start off with chapter 4, whether you're laughing or crying. Okay? Is that clear, girls? Good. So, yes, okay. Take this long weekend here as, okay, as a blessing. Review and review and review. And try to just, okay, go over these questions here by yourselves as well. Okay. Try to answer them. Yes, okay. If your answers are correct, good. If they're not, you can do yes, okay, go back to yes, okay, to the topic that is relevant and look at that. Or you can actually just, okay, look at the answer, because the answer is not just the answer, but in some instances, you also find the explanation for it. Okay. So yes, okay. See you girls on Tuesday. Enjoy your weekend. Have fun and take care.
Thank you.
Thank
Okay.
you.
You're welcome. Yeah.